One line is what makes possible the data type we have been calling string all of this time. But let me scroll down as another teaser to come with regard to pointers. If I scroll down to the documentation here for getString, notice that it says this. It reads a line of text from standard input, that just means keyboard, and returns it as a string, otherwise known as char star, sans trailing new line character. So in other words, even though you've been hitting enter at the keyboard, we do not hand you as part of the string that \n. Otherwise, every time you printed strings, they would move the cursor to the next line. So we get rid of that. Returns, this is what's interesting, returns null upon error or no input whatsoever. So it turns out there's a few scenarios in which getString cannot give you a string. Either somehow the bad guy has avoided hitting enter at all, but he's nonetheless said, I'm done executing getString. Or what's another situation in which a function like getString could fathomably fail? Like, what could a bad guy do that's just really annoying and breaks a function like getString, whose purpose in life is to get a string from the keyboard and hand you back a chunk of memory with that string? Yeah, what if it's a super, super, super long string, right? The appliance, recall, only has, by default, like 768 megabytes of memory. And some of you with netbooks and the like have had to crank that memory down to only like 256. So what if the bad guy, it's a little tedious, but typed in billions of characters on the keyboard, or really just did a whole lot of copy-paste to paste in a huge string, or the whole King James Bible, which you can just copy and paste from the web page and then paste at the prompt? What might happen? Well, getString might not be able to allocate enough memory from the operating system. And so what is getString going to do? Well, according to its documentation, it's not going to return that string. It's going to return a special character called null in all caps. And this is the absence of any actual memory, the absence of any string. But we'll come back to that. For now, know that this program is actually a little buggy because we're not checking if s is actually a legitimate value. We'll see in future weeks that, in fact, it could be itself flawed. Rather, it could be non-existent. And so we could get a segmentation fault just by trying to traverse it. So let me try another version here. Let me go ahead and open up a prefabbed file this time, string2.c. Because it turns out there's an inefficiency in this. So what I'll start to do now in lecture, so that all the answers are not always on the screen, is even though in the printout, on the PDFs online and the source code, which you're welcome to download in advance or bring to class on a laptop, I go ahead and with a little program, I strip out all of the comments, all of the one-line comments, so that it doesn't just tell you what's going on here. So that's why there's some empty lines here. And now let me actually point out this. This is the key to solving the problem I just alluded to, checking if s actually does not equal null. But again, more on that in the future. Let's focus instead on just this part here, which is almost identical to the thing I just implemented, but with one difference. I would argue that this implementation of string is worse than what we just did on the fly. This is more inefficient. This is bad design, so to speak. What's, damn it. Oh, I have to spoil the answer now. This is really good design. So what if, damn it, I opened the wrong version. OK, here we go. Let's put this over here. OK. This is bad design. What should we do instead? Well, let's try to, that question's clearly out of the bag now. Why is this bad design? Why don't you like this? OK, good. So remember how a for loop works. You've got the initialization of some variables, and that's over here to the left of the semicolon. You've got the increment over here on the right of the semicolon. That happens every time the loop goes through. And then remember this part, the condition. How many times is this thing checked? So every time you go through the loop. So what's the stupid design decision here? Even though this is nice and clean and readable, right? This is very succinct. It's one-liner. It's not ugly. But how many times am I calling strlang on s? Well, every time this loop goes around. So if I type in HELLO, what is strlang of HELLO going to be on the first iteration? 5. What about the second iteration? What's the length of hello? 5, and then 5, and then 5, right? The fact that I'm doing this like an idiot just means that you're doing the same exact thing again and again and again, and that's a waste. So we can do better than that in a couple of ways. One, we could do it in the manner I first did, where I said, you know what, give me a variable n and give it the value of str length of s, and then go ahead and do I is less than n here. So that fixes it. But if you don't like that syntax, you can actually do it in line. And this was that spoiler. N gets strlen of s. So notice now I have two initializations to the left. I can do a condition now based on that variable. And so this is just a marginally cleaner way of actually checking the length of s, but only once, because even though I is being incremented, we're not actually changing the length of that thing itself. So this is good design. The bad version that I changed it to a moment ago, we're calling strlen again. That's what we mean in the PDFs of the problem sets, that when we say grading with respect to design, look for those kinds of inefficiencies that might not be glaringly obvious, and they're not incorrect. They're just bad design. So let me go ahead and open up just one or so other things here. Let's take a look at this one. So this is a program, and this is actually slightly useful. It's kind of a calculator, but just for quiz averages. This is a program whose purpose in life is to ask the user for their quiz scores. Then it computes the average of those quiz scores and tells you what your average is. So marginally useful. But it introduces a few new features that are now going to be increasingly useful. So let's start at the top. In English, what would you wager this line is doing? So at least one verb in the answer should be it's declaring something. What's it declaring? So it's declaring an array. And I say that the verb should be declare because any time you see a variable data type like float or int or string, you're declaring something. So you're declaring an array. How do you know it's an array? Well, the clue today is just these square braces. Now, what is quizzes in all caps? We've not seen that before. Well, it turns out that a very good practice, also good design in a program, is if you need to use some constant value, like the number 2 quizzes per semester, it's best not to hard code the number 2 all throughout your program, but rather to factor that out, use what's called sharp define. So similar to sharp include, but the word is different, sharp define. You can then give the constant a name, and by convention, it is all capital letters, though it's not required, but that's what programmers do. And then the number that you want to make quizzes synonymous with. So it creates like an alias, so that when your program's compiled, anywhere the word quizzes appears, the number 2 is going to be substituted. Does it matter if it's an int or a double? No, we could actually do this. But you want to make sure to use, when you define a constant, you can make it almost any data type. This, though, would be bad here because when you declare an array with square braces, you must pass it an int. You cannot pass it a float. So what is going on here? We've not seen the syntax in a program yet, but this variable is going to be called grades. How big is this array going to be? Well, when you want to specify in advance how big an array should be, you just specify in square braces that number. So I could do this. And in fact, that is synonymous with what I just did. But again, the goal of a constant is to factor that out. Because look, just ahead, we don't know what this is doing yet. But notice I've already used quizzes 3 times. Just if you fast forward, if we ever had 3 quizzes, or God forbid 4 or 5 during the semester, you would then have to go change that number all over the place. And it's just too easy to make a mistake. Leave a 2 up here, a 3 down here, and now the program's broken. So we can standardize the number at the very top of the program. So in short, this gives me an array of size 2 mailboxes side by side, each of which can store a float as a value. All right, what were your quiz scores? Then we iterate from I is 0 up to quizzes. This is sort of old school now. So quiz number 1 of 2. So I'm just doing 0 plus 1 is 1. So this will literally say quiz 1 of 2. So I'm trying to make it more human friendly by counting from 1 rather than 0. And then what's this doing? Well, this is now the syntax. If you already have an array, and it's of big enough size, if you want to put something in the ith location, you just specify grades, bracket I, gets, in other words, the assignment operator, whatever it is you want to put there. So in short, what do these lines of code do? It declares an array of size 2, a mailbox with 2 slots. It then asks the user for their quiz scores, and then it stores those 2 floating point values in grades bracket 0 and grades bracket 1. That's all. So one number here, one number here. Let's go ahead and scroll down now. And now I'm computing the average, and this is it. So how do you compute the average of numbers? Frankly, this is very easy with 2, but we want to keep it general. You compute your average by adding all your quiz scores together and dividing by the total. So let's do that. I have a sum initially that's equal to 0. I then iterate from 0 up to quizzes, so however many quizzes I have. Then I can use this fancy syntax, plus equal adds to sum the ith grade. So once I get to this line here, what have I just done? I've stored in a variable called sum the sum of my two quizzes. So something plus something. Now I have a total, but now I need to get the average. So I need to divide by quizzes. And just so that I don't kind of screw you out of the A instead of the A minus, we want to make sure we round up or round down, because otherwise we would be truncating. Remember what happens when you divide something by an integer potentially. So let's go ahead and round. So we round up or down. The round function is in, turns out, the math.h header. So more about that online under cs50.net.resources. But this now stores an average, an integer, that's the result of rounding the sum divided by quizzes. So at the end of the day, this is just basic arithmetic that you could do paper, pencil, or on a calculator or in your head even. But what we've introduced now is the ability to store multiple grades in an array. Why didn't I just use two variables for grade 1 and for grade 2? Right? Float grade 1, comma, and then semicolon, float grade 2, semicolon. Why is that bad? Arguably.
There could be like too many quizzes.
Yeah. Exactly. What if I have a third quiz, a fourth quiz? Do you really want to start copying and pasting your variables and have grade 1, grade 2, grade 3, grade 4, grade 5, grade 10? No, rather you can put them all in the same variable called grades and then just index into it in this ith location. And so it's with these primitives, modeling strings as arrays and being able to reverse strings or arrays with for loops, that you'll be able to take something like hello and encrypt it, whether you're doing the Hacker Edition this week or the Standard Edition. So with that, we will see you on Wednesday.